Welcome to my Spring Security 4 demo. I moved through the steps quite quickly here in this demo to consolidate the information. So I added a few keyboard shortcuts. The left and right arrow I really like for fast forward and rewind. In case you didn't know that, I use it a lot. And also the couple down at the bottom are really good for slowing down and speeding up the playback speed. I'm going to start out here with Spring initialization, which is basically what Spring components you're going to need in your application to start the server. First off, you're going to need the required Maven or Gradle dependencies, which reference the Spring Security libraries. Since I'm using Spring Boot, I just need this one. If you're not using Spring Boot, look up the required references in the Spring Security documentation. Now we add the main class, which we do most all of our Spring Security coding in. It's got to have extend a web security configuration adapter. It's got to have an @configuration annotation on it, which basically tells Java it's a configuration class. And it's got to have an @enabled web security configuration on it, which basically connects it to the Spring Security framework. Now we add an auto-wired method called configuration global security. And in that method, we configure the type of data store we are using for authentication. Here I'm using authentication using JDBC, and I just added some inline username, passwords, and roles. You can add more of these to your database. So what happens in the background is that Spring Security has this authentication manager interface, and that extends the authentication provider interface, and that implements the particular class representing the data store you choose. There's more that I haven't included here. But since we chose JDBC, Spring Security is just going to use the DAO Authentication Provider class. Now I'm going to clean up the screen a bit. Now let's go through the entire flow of how a secure page is requested and then returned with Spring Security. Okay, let's say we open up a blank tab in our browser. We'll be requesting a URL, which contains a list of things you want to be secured with Spring Security. We'll call the page My Stuff. So basically, it does a get to the My Stuff page. So the request comes in and it sees a filter, which is also something that you're going to need to add to your web XML. Unless you're using Spring Boot like I am. Spring Boot basically uses a virtual web XML and the filter is added automatically. So the filter in the web XML tells all the requests to go to the delegate filter proxy class first. So that's what the request does. Now at the bottom here, I put the actual My Stuff secure page that we wanted to be displayed at the end. That's our goal. So let's take a look at the steps in between requesting that page and finally getting to that page. After passing through the delegate filter proxy and going through a bunch of steps here we'll show later, it runs to this configuration HTTP security method, which you need to override from the web security configuration adapter. And this method is going to check to see if the request is secured. Okay, so I've written just one line of code for this method, and this string of characters here says that if the request matches this, the logged in user has to be authenticated, and that user needs to have an authority of role user. Here we see ant matchers. Ant, the word ant is used because it's the language that's used in an ant build tool. So basically, because this /** is a generic set of characters for anything, right now I'm not specifying that this page acts any different than any other page on my site. All pages are secured with this one setting, this one line of code, and only can be displayed if the user is logged in and they have a role of role user. So the user needs to be logged in and they're not. we just opened up a tab and tried to hit this page here. So the request is redirected with a more general GET string. This is just the string Spring Security uses for any request that needs to be redirected to a login page. It then sends the request to the login page itself. Now the user just gives a username and password here and clicks login. That page then sends a post with the credentials and checks if these credentials now give the user the role user authority to access the page. If it does, then the request is again redirected, this time to the original requested page, and finally it returns the original requested page. Now let's go through and look more in depth at the details in between each of these steps. We'll start off with the steps in between the initial request and the first redirect. I'm going to clear out the numbers so we can add numbers to the steps in between. After the first step, the delegate filter proxy actually initially sends the request to a method in your security configuration class. Now this method is a good place to put resources you want to ignore. Here I'm telling it to ignore relative paths that start with the word resources. Now I could have put this code in this method along with this line of code here, but I'll get into the details of why you might want to do that sometimes later on. So the request passes to the next step. Why is that? Because the matcher looks for a relative path that starts with resources, and since my path is just my stuff, it doesn't match, so it moves on. And it moves into what's called the security filter chain. This is a collection of classes that are all linked together. The filter chain proxy is the first class to be called in the security filter chain, and it calls a method on another class in the filter chain. And that method in that class calls another method on the next class in the filter chain. And so on. I'll explain the added box here later. Incidentally, the name of the method that each of these classes calls on the subsequent class is called the doFilter method. I'm just including a few of the most important filter chain classes here, which I haven't given the names to you yet. I will shortly. Okay, now at the end of the filter chain, there's a class called Filter Security Interceptor. And this is a class that calls the configuration HTTP security method that we're calling before. So this is where it checks the code where we wrote previously, which says that all pages right here must be authenticated and have the authority of role user. Now note that a request starting with a relative path of resources, as we indicate in the method above, would be considered as any request. But since it comes in step 2 before, it would skip any step after 2 altogether and send the response directly to the client after step 2. So it would never get to step 3, and the all pages pattern here would not match there and would not apply to a resource page. So you might ask, why can't I just put this line of code here in this method instead, along with this line of code? I said earlier, actually you can. So let's do that. The code looks slightly different, but it's basically the same. Notice that I put it before the all requests matcher line. That's important. Once a request finds a match, it will ignore the rest. So if I had put it below the all request line, it would have never gotten to the resources match line, as it would match the first line first. Now note that putting this line in this method instead of the method above allows the request to go through the entire filter chain first. You may want to do this in some situations, even for requests that you want to ignore with the matchers. For method level security, for example, or for a resource you want to run through a custom filter chain class on. So in any case, we just have a simple case of ignoring the resource altogether and don't need to go through the filter chain, so we'll keep it in the configure web security method. Back to our original my stuff request here, as it does match the all request pattern and the user does need to be logged in with a role user, which they are not, as we said earlier. the filter security interceptor throws an access denied exception. Which brings us to an important point about the security filter chain. As I said before, each method in a filter chain class is calling another method on the next class in the filter chain. It's a doFilter method. After each method it calls is completed, execution is returned to the calling method. That's just procedural programming 101. So the exception is thrown back to the filter chain class that called it, and that class is returned to the class that called it, and so on. In any case, the next important class that this method returns control to is the exception translation filter, which catches the access denied exception. So now it needs to redirect the client to a login page, but once it does this, the original request will be lost. So it needs to store the original request. So it calls into the core Java libraries. Incidentally, all the other classes here are part of the Spring Security libraries. And it transverses the object graph from the HTTP servlet request object to the request cache object, which contains a holder, and it stores the original request there. Then it redirects. So the login page is the next thing that shows up on the client end. Let's take a look now at the steps in between the redirect and the login page. The redirect sends a generic GET request to the delegating filter proxy again, which goes to the filter chain proxy again and calls through several filter classes again, until control gets to a filter class called default login page generating filter. This class knows the login page that is registered for your site, so it returns that page to the client. Spring Security uses a default login page if you don't define one on your own. The next thing on the HTTP side is another redirect. So now let's take a look at the steps in between the login and this next redirect. The user enters his username and password and clicks Login. A post is sent to the server again as a generic string, JSpring security check, and along with that, the credentials the user entered. It goes through the delegating filter proxy again, and to the filter chain proxy again, and through some of the filter classes until it gets to the username password authentication filter, which extends the abstract authentication process filter. So, abstract authentication process filter can be extended by a few different classes. The CAS authentication filter, which is for single sign-on, the OpenID authentication filter, which is an open source authentication framework that allows you to use the same credentials on multiple sites, and the username password authentication filter, which is just the classic method of storing your username and password on your site, and it's what I'm using in this demo. So this class makes a call to the Authentication Manager object, which we set up at configuration time earlier. It holds all the credentials and role access, so it can verify if the username password pair that was entered has a match. If it doesn't, it will return a login failed message to the client. If it does match, it will create a user details object and store the credentials there. Now the user details object also has a property on it, which is a collection of granted authority objects. Okay, let's say we logged in as a user in step 7, as I didn't say which user we logged in as. Okay, if you remember, we set a user role to the username user in the configuration section. Since we are logged in as user, as I said, that role needs to be stored here. So the user's role user is copied from the Authentication Manager and stored in a granted authority for this user's user details object. Now the username password authentication filter creates what's called the authentication object, basically a more generic place to store who the user is. And it extends a class called principal, which is also in the core Java libraries and is another property on the HTTP servlet request. A principal is the common term found in web application languages. It's a place to store info about the current logged in user. So although Spring Security has stored some info about the user in the user details objects, core Java's principal actually includes info about the user as well. So the authentication object extends it to give Spring Security easy access to additional info about the logged in user. Okay, the next step is to store the user details in an authentication property. I could do that with a property like this, but actually that's a bad idea. It presents a problem. What I didn't mention before is that some authentication providers actually return a different class than the class user details, which was returned by our authentication provider. To allow for these other types, authentication must store its property as a generic object versus a user details type. So this won't work. What it does instead is it stores it as an object type. And since it's kind of Spring Security's own version of a principal, it names the variable principal. That can be a bit confusing if you don't understand it. So the user details type can be referenced by the principal variable, which is of type object because user details extends the object class. Of course, all classes do. So to show the connection between the two, specifically that a reference to user details is stored in principal, I show the user details extending the principal object. In reality, it's just extending the class object itself. So let's clean things up here to show how I had it before. One quick last thing authentication does is it makes a direct reference to the granted authority properties. That way they are quicker to access. And we can forget about the user details reference to them. So now that we have the user info in the authentication object, control moves back up the chain and is accessed by the security context persistence filter. This filter makes a call to the security context holder, and it stores a reference to the authentication object there. This is the central location Spring Security always goes to find the authentication object for validation. Security context persistence filter then makes a call to the request cache object and retrieves the original request. And just before it redirects using that info, it makes a call to the HTTP session object. Then it moves the reference to the authentication object there. It can't keep the security context holder populated because web application threads are pooled. Finally, it makes the redirect. So the next and last step on the HTTP side will be returning the secured page to the user. Let's take a look at the final steps to get there. The GET request is sent to the delegating filter proxy as always and goes through the filter chain. The security context persistence filter sees it and checks if there was a previous authentication object referenced in the HTTP session. As there was, it takes that reference, calls the security context holder again, and copies a reference to it there again. So we can forget about the reference in the HTTP session at this point. So control moves further down the filter chain. And finally, the filter security interceptor runs the code in the configure HTTP security method again. It then sees that this resource matches with a resource that needs a role user. So it checks the security context holder's authentication object to see if that object has been given that role. And of course it has. So finally it returns the secured my stuff page. Now lastly, let's take a look at a few more properties that can be controlled in our application in the configure HTTP security method. We'll hide most everything else. First off, you can add a custom filter to the filter chain like this. I've added a filter called My Custom Filter, which will be placed before the username password authentication filter. Next off, we can add code to prevent storing the principal or authority in the session. We did that here. Next, we can show how to allow access to the resource to anyone, even if they're not logged in. I actually showed how we can do this earlier in the demo. Now we can show you how to allow access to resources to all logged in users. So basically, there is no authentication required. Next, we see how to allow access to resources to only authorized users. Again, this is the same as was shown earlier in the demo. Remember that these lines of code must all be in this order to work correctly. Next, we see how to add a login form, which is actually the default action. Next is how to require HTTPS versus HTTP at login. Additionally, this requires all the subsequent pages that are after to be HTTPS as well. Next, we see how to use HTTP basic authentication in case you are doing a REST API instead of or in addition to a GUI site. And finally, I show here the ability to allow users to skip logging in after they return to your site in a certain amount of time. It stores a token for the login in a cookie. Okay, now for review, let's go through the global steps in the entire flow one more time. First is the initialization on startup, which sets up your user info data store. Then the first pass through the server is taken, which determines if the path requested matches a path that requires authorization and/or authentication. If the user is logged in, it goes to step 17 in the last pass section. And if the user isn't logged in, it stores the path requested and redirects to a Spring Secure login. Then the second path finds the login page you have registered on your site and returns that page to the client. Then the third pass validates the user's login, stores the validation details for subsequent requests, and redirects to the original path requested. And finally, the last pass, again, determines if the path requested matches a path that requires authorization and/or authentication, verifies that the user is logged in and has authorization if needed, and returns the secured page to the client. Thanks for watching my Spring Security 4 demo.